Right, good morning, grade 11s. Doing the Eastern Cape Analytical Geometry 2017. It's out of 15 marks, so realistically this should take you about 15 minutes. I'm going to try and throw some advice in, as a tutorial as we go through this question, but let's have a look. Right, first things first, there's the drawing you've been given. Now, before I continue, please make sure that this thing is open, that you have it in front of you, that there's a pen and paper in your hand and you are actively learning. Anyway, alright, so it says there A, B, C, and D are the vertices of a quadrilateral. We don't know what quadrilateral it is, such that diagonal AC is perpendicular to BD. So we already get an indication that the quadrilateral can either be a square, a rhombus, or a kite. Those are the quadrilaterals that have perpendicular diagonals. Right, the equation of BTD is given as this. Right, now hopefully you've already recognized this as a straight line. But in order for it to be a straight line, we obviously need to make y the subject. Alright, AB is 15 units, and the coordinates of A are minus 2 and minus 5. Right, for 2 marks, determine the gradient of line AC. Now, we know that BTD is given as this. Now, generally, if it was the gradient, I would try and look for A to C, or at least A to T, but I don't have T's coordinates or C's coordinates, so what are my other options? Well, if I get BTD's coordinates, then I know that the perpendicular gradient is going to be the reciprocal additive inverse. Right, so I'm going to make y the subject, so 2y equals negative x plus 18, divided by 2. Now, you could just throw a line and say divided by 2. The thing is that I want to make sure that I have a gradient and a constant. So I'm going to divide everything by 2 individually, right? Which makes this negative a half x plus 9. Right, am I happy that this is a negative gradient? Yes, because it's going downhill. Right, so this then is the gradient of BD. So therefore, M1, M of BD times the gradient of AC will equal minus 1. Now you don't need to go through all these calculations for 2 marks. You could have quite easily said the gradient of AC is going to be 2, but just for your own benefit, negative a half times the gradient of AC will equal minus 1. Divide both sides by minus a half, so the M of AC equals 2. Right. Right, next question. Determine the equation of AC in terms of y equals mx plus c. Well, that was once a scaffolded question, so basically you found the gradient from the previous question, which you'll now use in the next question. So both of these questions have now been made routine questions. If I just said from the beginning, find line AC, that would then have been a complex problem solving, because you would have had to do more than one step to get there. Right, so we know that the formula of the equation is y equals mx plus c. We now know that the gradient is 2. Right, how many unknowns? 3. Now we don't know how to solve equations with 3 unknowns, so which means that there can't be all 3 unknown. I know that line AC goes through A, which I have a x and a y value for, so I'm simply going to put it in there. That's minus 4, add the 4. So your final answer, y equals 2x minus 1. Okay. Alright, and you'll notice on your drawing, the y cut is actually down here, so my drawing's a little bit off, but just have a look there. Right, next question, 3.3. It says, if the equation of AC is y equals 2x minus 1, yes, nailed it, calculate the coordinates of t. Right, now, what is T? T is the point of intersection of AC and BD. So how do we find a point of intersection? We simply equate the 2 functions. So, right, that was the formula we were given earlier. This is the formula that we've just figured out. In order to find a point of intersection, it's technically a simultaneous equation because that's where two functions are equal. So I'm simply going to say that that equals that. Right? Numbers that way, things this way. So 2 plus half is 2.5. Right, now, personally, I'm going to times by the 2 and then divide by 5. The thing is, how do you just get rid of a coefficient? You can simply divide by the coefficient. And if you said 10 divided by 5 over 2, you're going to get 4. Let's go the long way. Right, now I've got the x value. Does that mean I stop there? No, because they wanted the coordinate of t. So I know the x coordinate of t is 4, so I can choose which one to sub into. Generally, we sub into the easier one. So y equals 2 times 4 minus 1, which is going to be 7. Therefore, t is 4 and 7. Right. 3.4. A, B, C, D is a kite. Alright, now we know it's a kite. So the fact that it is a kite means that this will equal this, that will equal that, what else? That side will equal that side, that triangle is congruent to that triangle is congruent to that triangle. So it's very loaded when a question tells you that it is a specific type of quadrilateral. Right, now they want the coordinates of C. I've just worked out this to be 4 and 7. Right, now how many marks is that? That's 2 marks. So if it's 2 marks, not much work to do. And again, most of these questions are scaffolded, which means each question is leading on to the next question. So why did I just figure out T? And if I've got A, so well, what do I know about a kite? I know that this is equal to this, which means the distance from A to T will be the same as from T to C. Now remember, distance is a change in something. Now if I want to be very clever, I can simply use changes in gradients. So for example, how does minus 2 become 4? You add 6. So what am I going to do to this 4? I'm also going to add 6. How does minus 5 become 7? We add 12, which means this is going to be 19. 2 marks. Right, calculate the length of BT. Right, how am I going to get BT? Well, if it's for 4 marks, which means there is some work to do over here. Now, I know that this is a right angle triangle, and they want BT. They've given me this 15, and that's another thing with these questions, is if you ever run into, like if you're stuck, always ask, go back to what they have given you and why. If you haven't used it yet, then maybe it's a good time to go back and find out why they've given it to you. Right, so the first thing I'm going to do is I'm going to find out the length of AT using those coordinates, and then I'm simply going to use Pythagoras to find out the other side. Right, so remember the distance formula is basically Pythagoras. So AT squared, the change in x squared, 6 squared, change in y squared, 12 squared. Add that and square root it. There's my calculator. Right, it didn't specifically say whether to leave it in surd form or to round it off to 2 decimal places. Generally speaking, you are safer to round off to 2 decimal places. However, if I'm going to use this distance again, I'm rather going to use the surd form because that way I don't have to round off and lose any decimal places. So, right, I'm not done with the question yet. I'm still trying to work out BT using Pythagoras. Now remember guys, BT is not the hypotenuse. So BT squared will equal AB squared minus AT squared. So BT will equal AB is 15. Right, I'm going to work that out, square root everything to get BT alone. Right, again, don't take my word for it, please make sure you are doing this yourself. If you watched this before you actually did the work yourself, go back and try and do it again by yourself. Alright, last question. Write down the length of the radius of the circle passing through points B, C, and T. Right, now, we haven't done this yet, but a diameter always subtends a right angle, which means BC would then be the diameter, because it's subtending a right angle at T, which would make BC the diameter. Now, it says write down the length of the radius. Now, we know that that is 15, which makes this also 15 units because it's a kite, which would make the radius then 7,5. Right. You don't need to worry too much about that question. We haven't touched on any Euclidean analytical geometry yet, so other than that question. Right, the rest I assume you should be able to do, so good luck.